Now, we are in the middle of a fundamental shift in AI into one of agentic systems, AI that can plan, reason, remember, coordinate, and act over time. And with that shift comes a simple question. How do we move from black box autonomy to something we can actually trust? Now, the adoption curve for agentic AI is accelerating. Post 2023, we're seeing an explosion in both research and real world deployment. Teams aren't experimenting anymore, they're building. The takeaway isn't panic, though, it's urgency. The systems we design now will define whether agentic AI scales cleanly or collapses under its own complexity. Now, you see, traditional AI agents were reactive and narrow. They handled single tasks in isolation with short-term memory and fixed workflows. Agentic AI systems are different. They are goal-driven and adaptive. They coordinate across specialized roles, they maintain persistent memory, and they orchestrate work dynamically. This isn't just more automation. It's the emergence of machine collectives. Now, with that power comes new risks. Agentic systems introduce failure modes we didn't have before. Autonomy abuse, where objectives are misinterpreted, persistent memory contamination, prompt injection and reasoning traps, agent collusion, and cascading failures. These are system-level risks, as you might recognize, and system-level risks require system-level controls. The chat dev example in this paper illustrates a critical failure pattern. Planner agents design something flawed, coder agents implement it, tester agents validate it against the same flawed assumptions. Without external ground truth or governance, agents simply reinforce each other's mistakes. Sounds very human to me. Collaboration amplifies error instead of correcting it. Now, that's not a model failure, that's an architecture failure, though. This is where the paper introduces TRiSM for agentic AI. Trust, risk, and security management. Not a policy, not as a checklist, but as a system-level blueprint for building and operating reliable agentic AI. TRiSM moves the conversation from can we build this to can we run this responsibly at scale. The framework rests on 5 pillars: explainability, model ops, security, privacy, and governance. And together, these pillars make autonomy operational, not fragile. Explainability here doesn't mean exposing every token. It means traceability, decision lineage, reasoning provenance, and auditable flows of both data and actions. Model ops extends this into practice, versioning agents and prompts, monitoring behavior, and introducing safety gates, much like CI/CD, but for agents. Agentic systems now widen the attack surface. TRiSM suggests we respond with concrete defenses like prompt hygiene, sandbox tools, execution separation, privacy-preserving techniques like differential privacy, and trusted execution environments. This is about engineering trust. One of the strongest ideas in the paper is measurement. TRiSM introduces metrics like component synergy score to measure whether agents work better together. And another one they introduce is tool utilization efficacy to measure whether tools are used correctly and safely. TRiSM aligns naturally with global standards like NIST, the EU AI Act, and ISO frameworks, among others. More importantly, it gives teams a starting path to map agentic initiatives, assess risk, implement foundational controls, and test continuously. This is how agentic AI becomes production ready, it seems like. For more, check out the paper in the description box below, and thank you so much for watching.